Lah. Hello guys.
The Bluetooth device is ready to pair. The Bluetooth device is connected successfully.
Hello guys, welcome again to my YT channel. This is the second segment of my discussion regarding soil chemistry. So we need to go back because my first live stream was not very good. Okay, it has a lot of pauses. It is missed out several times because I am interrupted, disconnected. Okay, so I have to go back. Just read this one. Okay, it's very easy, right? It's self-explanatory. Okay, right? Soil composed of organic matter, and then organic matter composed of small residues, the small organisms, and the humus active matter, the active organic matter. And we have also the organic matter composed of 45% of minerals, 25% of water, air. And now we go to the minerals. Okay. We have the alumina or the silica. Okay. We have the magnesia or magnesium. Okay. We have the alumina, aluminum, silica like that. Potassium, calcium, magnesium. Okay, sodium. Okay. And iron. Okay. And now we go to the general components of the soil. Okay. It's gonna be SSS. Okay, here SSS. It's not social security system, but this is sandstone, and shale. So I should know this are the raw materials of cement production. Okay, sandstone, and shale, something like that. There's also one, but this is not the raw material of cement production. It is silt, it is ILT. Because it's a combination of moisture for that. Okay, but we will not consider that here. Okay, only the sandstone, and shale. And now let's investigate their components, individual component of this sandstone, and shale. Okay, let's go first with sandstone. Ano sand? Okay, sand is soil, of course. Okay, sand composed of mainly the larger percentage of sand is really again SiO2, silica or quartz. Okay, silica, SiO2 or quartz. Before we can come up with the answer, let's really investigate why. Okay. Okay. Sand composed mainly of silica or SiO2 for the quartz. And then we have number 2, the calcium carbonate or the limestone. Okay. Calcium carbonate or the limestone is also one of the materials of production of cement. Calcium carbonate. This is a type of rock, something like that. Limestone. Okay. And the specific example for this, it exists as a aragonite. Okay. Aragonite. Okay. Actually, there are also other allotrope. The term is allotrope because allotrope in chemistry means a chemical element that produces several forms of the same physical state, like the graphite and the diamond. They are all solid, okay, but they exist in different types of forms. Okay, that's allotrope. Okay, you should know the difference between an isotope, an allotrope, and an isomers. Okay, if you want to really to take up this chemistry or other related chemistry courses. Not so much with chemical engineering, because chemical engineering are more mathematics and technology, right? Something like that. But if you want to pursue career more on chemistry, really, if you're taking your master, PhD, something like that, chemistry, then you have to know this components, mixtures, substances, because these are really the details of taking or pursuing master's or PhD in chemistry. Okay? But anyhow, some also chemical engineers will try to take this chemistry because more or less this is very close, right? But most of those individuals taking up this chemistry and PhD in chemistry or doctors in chemistry are usually graduate of BS chemistry, okay, Bachelor of Science in Chemistry. But there are also a lot of chemical engineers there, okay. Okay, you get the point, something like that. Because most of the chemical engineers or mechanical engineering graduate will take the MS chemical engineering also when they proceed to master's or doctor in chemical engineering, something like that. Not necessarily a licensed chemical engineer, but when you finish chemical engineering, you can really proceed master's in chemical engineering or doctor in chemical engineering. Okay, because the registration and the licensure is only needed in working in the industry. Okay, sometimes they need that because they need to sign a document. Okay, something like that. The licensed chemical engineers are only the qualified to sign a document. Okay, so those are not licensed and registered. You cannot sign the document, or you cannot create your own chemical business if you don't have license as a chemical engineer. You need to make your own products. Okay, there's a in Philippines that is only the restriction. Okay, for example, me, I will make a business regarding producing chemical products. I should have a license being a chemical engineer so that I have a business for the production of those chemical products. If I don't have that, then I cannot do that. I will hire a licensed chemical engineer to create a business. Okay? Because it will be scrutinized during application of the permit to operate of your business. Okay? Especially chemical products. I will share you to you that because last year there is one mechanical engineer talked to me and he said he will buy my license. Really, he will borrow my license and he will just pay my license. Okay, maybe RC license. He want to manufacture, what's the manufacture? Water treatment, something like that. And he is a mechanical engineer. He's not a chemical engineer. Okay. But then you are producing chemical products ng siya. You are manufacturing chemical products ng siya. So needed man yun siyang licensed or registered chemical engineer, especially if you are the owner. Okay? That's only the restriction. But if you try to proceed MS chemical engineering or doctor in chemical engineering, it is not a requirement. Okay? That's the point. Even though you will make your own books, it is not a requirement really that you are a registered chemical engineer or a licensed chemical engineer to make your own book in chemical engineering. Okay? Because it's more on related in the academe, not on the industry. Okay? You get the point already? Only that restriction. Okay? But a lot also, especially abroad, doesn't require license card, okay, and registration card. But most only in the Philippines, in the country of origin. Okay? Like so it's very competitive there. That's why most of the chemical engineering graduates are working abroad. Okay? Like that, something like that. Okay, but in my part also, my company, they really see and scrutinize my PRC license part before I was accepted being an office engineer in our company. Now, the interviewer really find my PRC card during the interview, and I was shocked because normally it will never be asked in abroad. Okay, now I understand. I got pala shock. Okay. Okay, really. Okay. And then at that time, I present, and it's very late because I left my PRC card in the home. And then one interview, where is your license card, like that. And it called my sister, just scan that, listen to the interview, just like that. So things like that is never expected, right? Okay, because who will expect for that working abroad needs a PRC license card? Okay, maybe because they will only pick up one safety engineer, something like that, out of thousands. Really? Really? Because thanks that I'm the only one accepted. Okay? Talaga ganun siya ka, ano, uh, okay, go back to the topic. Number 3. Calcium carbonate is a limestone, and the most specific example of this is granite. Okay, so there is still other forms that exist for this, and I couldn't remember. Maybe anthracite. You know anthracite? I think it's coal. COAL. Okay, because coal also have different forms. It will exist in so many forms. So I'm telling you guys that that is allotrope. Okay, allotrope, the same chemical elements that will exist in different forms, but the same physical state. For example, all solid, all liquid, like that. Not the same with mercury. There's liquid mercury and there's solid mercury, right? So that is isotope. Okay? But here, the phase is just the same. Okay? Like that. Okay, that's also the same with isomers. Isomers more on organic chemistry also. The same chemical formula, but then their orientation and positioning. Okay, when you break down that one in the laboratory, you get a sample. Of course, you break the molecules, the bands, usually polar bands, non-polar covalent banding, H to H banding, hydrogen banding for the dipole-dipole interaction. Okay? Oh my gosh! Thank you that I still remember those banding in chemistry. It was 20 years ago. Oh my gosh. Number 3. Okay, calcium carbonate. And the next one is the gypsum. The gypsum, guys, will add quality to your cement product. Okay, so the gypsum also can be subdivided into allotropes. What are those allotropes? The first allotrope of gypsum, or the calcium sulfate, okay? Calcium sulfate is the gypsum. Hydrated calcium sulfate. When you speak about hydrated class, there is an addition of water. Okay, meaning aqueous solution. Okay, if you need that in chemistry problem solving, if the problem will state aqueous solution, meaning water is present there. Not necessarily that they will give the word water or it's automatic aqueous. There is water for that. And sometimes also problems in chemistry or physical chemistry or whatever, okay, we'll never also put the word water or H2O. So they will just give aqueous sulfate will decompose into blah blah blah. Ikaw pa ang mabuhat ng formula, ikaw pa ang mabuhat ng reactants, then ikaw pa ang mabuhat ng product, and you'll be the one also to balance the chemical reaction. Okay? Sometimes it's just like that. And you have to think, oh, aqueous solution is having water. Not. Why aqueous? Because of the word aquatic. Aquatic environment in the sea in which the fishes are living. Okay? Like aquatic marine animals are living. Their habitat, their aquatic environment. So the word aqueous coming from aquatic chaos. Aqueous, aquatic. Ganon. That's why it is aqueous because there's water. Okay, ganon siya. Or aqua. You heard the word aqua that have water. Okay, aquaculture. Ganon. There's a word, there's water in it. Okay? So, calcium sulfate pa. Unahon man na itong formula, no? Okay, so calcium sulfate. Salt, right? Calcium, because ATE man siya. Calcium sulfate. Okay, this is gypsum. Example, a lot of gypsum. And, oh my gosh, are you familiar with this? Selenite. Selenite. Okay. What is selenite, Sir Sotero? Selenite, the composition of a selenite is just, hydrated with 2 moles of water. But still, you have to add calcium sulfate for that during the mixture. Okay? So you can analyze that in the laboratory also. Okay? And then you can solve for any quantities you'll be able to require. Okay? Like this, the gypsum. Okay, gypsum is SO calcium, sorry, calcium SO4 times 4 moles of water. Okay. So remember, class, if you speak about gypsum, there's water already for that. Built in. Okay. Partnership, conjugal relationship with each other, banded with each other, combined with each other, mixed with each other, linked with each other, okay, joined with each other, okay, compacted with each other. I am referring they are contacting with each other, okay, as a compound. Okay, that's highlighted compound already. Calcium sulfate react with four moles of water. So that will become gypsum. Okay, our selenite is still calcium sulfate times 2 moles of water. Okay. So, Dora kay siya. It's very easy to memorize. Okay? Selenite ko, 2 moles of water. Ganon. Gypsum ko, 4 moles of water. Bingo. You can put that in your brain cells. Okay? So those are calcium sulfate, allotroph. Ganon. And now after that one, what else is there over this? We have also the ano? We have also the feldspar. And the feldspar, 25% feldspar. Oh my gosh, 25% feldspar. Okay. Okay, 25% feldspar. This is also known as the Arcos. Sometimes the terms really is very difficult, right? Because we don't encounter that. All we have to do to become a wide reader. A wide reader. Understand the point? Wide reader, keep reading and something like that. And if you found it interesting and you're not familiar with for the very first time, then memorize, research the meaning of that term so that you can easily understand what it refers to, what is that all about, so that it adds learning for you. It adds knowledge for you. So that when you next encounter those terms, you can really understand what is that all about. Okay, and then you can easily interpret the paragraph, the sentence, because you know already the terms reflected in those paragraphs and sentence. Okay, that's gonna be the technique in understanding the terminologies. That will be helpful to understand to solve problems, especially in science problem solving. Not only in science problem solving, also engineering problem solving, general engineering. Okay, that involves a lot of mathematics. Oh my gosh, loaded with mathematics. Number 3, 25% feldspar. Sa man siyang feldspar sa pero man siyang arcos. Feldspar. Feldspar is very unique. Feldspar is very unique because there's a lot of elements involved in it. Okay? Ganun siya. Okay? There's an aluminum, there's a silicon, and there's an oxygen. I think there are 4 elements banded together in this feldspar. That's why the 25% pala siya. Because there's a lot of bonding moment with each other. Okay, for example, calcium, aluminum, silicate. Ano ba? Isumpot rin siya ang silicate. Okay? Observe this how I present the compound because it really helps us to answer the question in the chemical engineering board examination year 2000, May 2000, our time. Yes, I could still remember exactly. Okay, what is the main component of soil in the Earth's crust? A, silicon, B, oxygen, C, nitrogen, D, aluminum, E, iron. Okay, and you gotta just get that. You need to study soil chemistry in order you can understand that. Or you should become a wide reader to answer that. You cannot guess. Okay? You cannot guess that. And it's not a problem solving, it's a theory. Okay? Okay. So calcium, aluminum is iO2. And then we have the sodium, aluminum, silicate. My goodness. Okay? Nakakaloka, no? Sodium, aluminum, silicate. And we have also the potassium, aluminum, silicate. Guys, always add the silicate and bingo. Okay, and just determine the exact formula of the silicate because it will vary. These are allotropes, huh? These are allotropes of feldspar. These are chemical elements in various forms, but exist in the same state as a solid that are called allotrope substances. Maybe it will come up also in the board examination. Blah are the chemical substances state. Oh, A, isotope. B, isomer. C, isovolumetric. D, adiabatic. D, allotrope. The answer will be allotrope. Okay, theory question. Okay, like that. So memorize also the silicate formula, ha? And please inject that in your brain cells. Every time, memorize and check in your brain cells. Ganun lang siya. Okay? Zoom in. Oh, ganon. Okay. Number 4. Charot. Kaloka. Oy. Magnetite. Pinansa naman eh. Grabe na siya yung mga term. Magnetite. Remember class in organic chemistry, if you pay too much attention for that, okay, what I mean is you are serious in studying chemistry, okay, you can absorb that there's a lot of existence of, or allotropes of iron oxide. You know iron oxide? Iron oxide is one of the components of the sandstone. Okay? Or component also in shale, SHALE. Okay, take note, iron oxide can exist as a ferrous, okay, ferric ferrous, Fe positive 2 charge in the outermost shell, and also ferric positive 3. Okay. The Fe positive 2 will react to oxygen to rapid oxidation, okay, that is hematite. Ganun talaga, if you want to become a chemical engineer, okay, hematite. Okay, what's hematite, Sir Sotero? Fe2O3, that's hematite, or iron oxide. Okay, but to avoid confusion, just use the iron 2 oxide. Okay, to avoid confusion, or ferrous oxide represents positive 2 charge of the iron. This is common in the corrosion process. Corrosion, especially in the acid rain, you know the brown color and the reddish color of the rain, and it will react to iron. It will produce something like that. Like it could be a ferric oxide or a ferric chloride somewhere along the way, and the color will be something yellowish because the chloride is yellowish. You're gonna orange, reddish, orange. Corrosion process. Okay. Okay, that is FeO2 plus. Now Fe2O3 is a hematite. Now, so hematite. Grabe na. Hematite. Sorry. Fe2O3. And then other allotrope for iron oxide is magnetite. Magnetite class is the most conductive compound in the soil. Is the most conductive component in the soil because of the word magnet. Magnetite. Now, if it will come in the board examination and it will say, what is the most conductive compound in the soil? Your answer will be Fe3O4, magnetite. Because sometimes the choices will not say the words. Sometimes only the formula. And if you know magnetite, then you can answer. If you don't know what is magnetite about, there's a lot of compound, then you lost. Okay, that's why you memorize that magnetite is Fe3O4. Okay, because that is the most conductive compound present in the soil. Okay? One additional information, chemical engineering or chemical engineering students there will take for examination. Magnetite is the most conductive compound present in the soil, in the Earth's crust. And then that's why it's called magnetite because of the law of magnetism. Okay, so magnetite is Fe3O4. So you should memorize that iron oxide exists in two forms: the iron 2 oxide and the iron 3 oxide, the ferrous oxide and the ferric oxide. And these are all components in shale and in sandstone, the raw materials of cement production. Okay, ganon. And then we have also the glauconite way, fairness. What is glauconite, Sir Sotero? Basta yung man ang class, first year ka pa lang sa chemical engineering, you have to memorize all that will end ATE, all will end ITE. Ganun, because it helps a lot. This is aragonite, glauconite, hematite. Ganun ba? Okay, chloride, chlorate, sulfate, lahat siya, i-memorize mo siya talaga. Okay? So, glauconite. So, what are the components of glauconite? Charot. Okay? Anthracite, di ba? Limonite. Okay, those are chemicals. Okay. So, glauconite. Pero glauconite, ano man siya? So, it's still the same, but it will just trick you out with the oxides components. Okay? So, potassium, calcium, magnesium, sodium, iron, oxide or oxygen. Ganun siya. So then you will add oxygen. It will become potassium oxide, calcium oxide, magnesium oxide, sodium oxide, iron oxide, and the oxides or the oxygen content. Like that. So these are all the components of glauconite. Okay? Like that. And then what else? Okay, what else? Let's think of another. Chloride. Still a very small only chloride. What's the formula of chloride? Chloride. We have chlorate and chloride, right? And then polyatomic ion. We have also hypochlorite, hypochlorate. What is the formula of chloride? Remember, there's ClO4 or not? Remember, ClO4. Because the identification of a chloride and chlorate, we have to add oxygen lang talaga siya in an element. Okay? Something like that. So, for example, chlorate. So that is ClO3 subscript. Okay? Chloride, ClO2. Okay? Like that. And what is the charge? This is negative. Okay. ClO2 negative 1 charge. ClO2 negative 1 charge. So chlorate and chloride are partners, conjugal, okay, partners, jowa. Okay, they are partnered with each other, the chlorate and the chloride. And then the hypochlorite and the hypochlorite just add hydrogen atom before the chlorine. Okay, sometimes also hypochlorite react with something like this. What are the products? And then you don't know what is a hypochlorite and a hypochlorite. Okay, basta ang ends with ATE, that is higher subscript, normally 3 or 4. Okay, just like phosphate, right? Phosphate, form ng oxygen, phosphate. Okay, then sulfate. Okay, so it's just same like that. Okay, you've got oxygen. Blah, blah, blah. You know the rule. You know the rule. Okay, something like that. All right. What else? Ano pa man siya? Common kayo na siya sa cement production. Okay. This is the kaolinite or the kaolin. Okay. You know that one? Kaolin. CaOLI. What is the formula of kaolin or kaolin exercise? Okay. The formula is for the aluminum silicate. Aluminum silicate. Okay. Al2Si2O O5 times the parenthesis plus an open parenthesis hydroxide times 4. Ganun siya ka-difficult yung formula. Again, El2, Si2, ganun, El2, ganun, O5, then OH4. OH, then subscript 4. Ako iswat ha, ang kaulinain. We speak about kaulin at that refers to kaulin manggod siya. Murag nga na lang siya. For example, just like, what do you call this one? Aqua oxinada, that is hydrogen peroxide H2O2, and muriatic acid. Muriatic acid is also an HCl. It's the same thing, right? So if we speak of kaolin, it's also kaulinite, something like that. Okay? Understand the point? Something like that. It's the same. Okay, just like silica. Silica is also silicon dioxide or quartz, something like that. But the same. Okay? But we are only familiar with silica. Okay? We don't use normally the quartz, but it's just the same. It's just like this also, kaolin and kaulinite. Okay, so kaolin or kaulinite, okay, like this. The color of this kaolin naturally is soft mineral white, something like that, and then it will become red or orange if it will react to iron oxide in the soil. You know na iron oxide is really reddish, something like that, or a little bit orange. That's why it will occupy the color during the reaction with this kaulinite. Okay, which is El2, Si2O5, close and open parenthesis, OH4. Okay, kaulinite. Or kaulin lang siya, pwede naman ito. Okay, El2, Si2O5, OH, ganun. Okay. This is the formula of kaulinite or kaolin. Okay. This is all about sand. And now we go to the second S, which is the sandstone. What is the component of sandstone? Basically the same class. The major component also are quartz or silica, aluminum oxide, iron oxide. But this time, there's an introduction of the lime. What is a lime? What is the lime? We have limestone. We have also the lime. Limestone and lime is not the same. Because when we speak about limestone, there's a carbon. And lime, there's no carbon. That's only an oxides of calcium. So calcium oxide. Okay? Lime water, there's an hydrogen ion. So that becomes calcium hydroxide. Okay? Calcium hydroxide is lime water. Okay, calcium oxide is simply lime. Calcium carbonate is limestone. Okay, you know the point already, the difference already, right? Okay. Okay, and the sodium oxide also. Again, the components of sandstone are silica quartz, SiO2, aluminum oxide, Al2O3, okay, iron oxide, Fe2O3, and calcium oxide, which is the lime, and then the sodium oxide, Na2O, and the potash. What's potash? Potash, from the word potassium, the formula is just only Ko, di ba? Kasi special. K2O, the same as in O2. Sa pa, sodium, kasama na siya. Sodium or sodash. Yes, sodash. Sodash, potash. Okay? Sodash meaning from the word soda. If there is sodium, that is soda. I think soda is the Greek term for sodium. Okay? That's why we have sodium chloride. That's Na. Okay? Sodium, soda. That's a soda, okay? Soda. So if we speak pala soda lime, that is sodium hydroxide. Okay? Okay, something like that. You understand the point now? Just add H na lang yun siya. Kung minun lime water, ganon, whatever, hydrated water siya. That's the components of the sandstone. Now go to, oh my gosh, we go to the last S. This is SSS, ha? The last S will be the shale?
Elementary.
Oh my gosh, sorry, lobat din ako. Okay. Shale is S-H-E-L-E, composed of, let's break down the components of shale, okay? You can really identify this class in the laboratory if you get a sample, especially in cement production, okay, or in mining industry. Okay, you need to get sample in the laboratory and you have to test that, okay, so that you can determine the components individually of the shale compound, okay? Okay, the shale composed of, okay, composed of 58% clay materials. Oh my gosh. Again, 28% silica or quartz. Okay, 6% feldspar, 5% carbonate materials or carbonaceous materials, 2% iron oxide. Now, if we try to summarize this soil chemistry, the most common of all is silica or SiO2 or quartz. Now, silicon is very common in shale, sandstone, sand, and minerals. So the answer for this chemical engineering board examination question, what is the most abundant component of soil, is silicon. Okay? Any objection? Silicon is the main component of soil in the Earth's crust. It's not aluminum. It's not magnesium. It's not calcium. It's not iron. It is silicon, the present in silica or quartz. Because as you can notice, we discussed in the minerals, minerals composed of 45% highest, right? And then the water is only 25, and the other ones are 55. The rest will be the, the inorganic like that. So quartz or silica are always mentioned in this general components of soil, which is highest siya sa sand, okay, sa silica, sa shale, like that, okay, sa sandstone. So common siya, top siya. So silicon is the answer for this. And I answered also silicon in the word examination. Oh my gosh. Okay. Because I read that also in my free time. The sand like this, composed of silicon like that. And then when I take the examination, it flashed to my brain cells. Oh my gosh. And then I choose the silicon as my answer. Actually, I don't memorize. I just read. Okay? Like that. And the helium also come out. Helium. What gas necessary in diving under sea level? What element is responsible to take inhalation during diving underwater? A, oxygen. B, helium. C, nitrogen. Ganun din. I answered also helium for that. Okay, just like the balloon needs helium. I don't know if it's correct or not, but that's my answer. Okay, thank you so much for this short live stream. I hope you guys like this live stream of mine. Thank you so much for watching. If you want to click the notification bell, then you can click for some news updates. I'm singer, eternal voice. Pasensya na talaga soil chemistry at this point in time. Okay, soil chemistry, solid substance, and then we go back to gas substance and later on properties of gases because I love really gases. Charot! Okay, and then you can comment down below in the comment section. Thank you so much. Again, guys, thank you so much for sparing your time with me once in a while because my revenue is rising. Thank you so much. Okay. Bye-bye. God bless everybody. See you later.